Hello, viewers. You're welcome back to class. I'll be teaching sequences this time. I've dropped a video on sequences and rules some couple of weeks ago. I just want to continue with sequences now. And on my last video, I spoke about forming or creating sequences with different rules and different starting points. There are many possible different sequences. When you have your first term and the rules that connect the terms of the sequence, you can always have many possible different sequences with your first term, with the rules, the one we call the term to term rules. So you're gonna have many possible different sequences. The first term, the numbers in a sequence are called terms. All the numbers in a typical sequence, they are called terms. But the first term, which we can also call the starting point of a sequence, is called the first term. The starting point of a sequence is called the first term. The rule that connects the term in a particular sequence is called the term to term rule or next term rule. So we have the first term, which is the starting point. We have the term to term rule, and the other important term, or we can also call it the general end term formula of a sequence, is the rule that connects the terms of a sequence to its position in the sequence. The rule I spoke about the other time is just the term to term rule, connection between the terms in the sequence. But when we come into the nth term of a sequence, it is the rule that connects the term of a sequence to its position in the sequence. So for n term is in relation to its position in the sequence. Like the question on board now, what is the first term to term rule, and the end term formula of the sequences below? The sequences on the board, there are three sequences. The first one is 2, 4, 6, 8. I just want to discuss it before writing it down. If you look at the first sequence, the first term, which is the starting point, is 2. And if you look at the relationship between the first term and the second term, you discover is a difference of 2. From second term to third term is a difference of 2. From third term to fourth term is a difference of 2. So the rule for the first sequence on board now is add 2. You add 2 to get the subsequent term. So the first term is 2. You add 2, you get the second term, which is 4. You add 2 to 4, you get the third term, which is 6. You add 2 to 6 to get the fourth term, which is 6. That's for the first term and the rule. For the first sequence, which is 2, 4, 6, 8, the sequence continues forever. The first term the first term, which is the starting point, is 2. The rule that connects the terms of the sequence, the rule is add 2. The rule is add 2. And lastly, for the first sequence, the nth term formula, the nth term formula of this sequence can be gotten by looking at the rule and looking at the first term. We look at the rule. What is the rule? The rule is add 2. What is the first term, which is the starting point? It is also 2. So when the rule and the starting point is the same thing, when the rule and the starting point is the same thing, when the rule and the starting point is the same, since they are the same thing, 2, the first term is 2, the rule is 2. So what we write is, the rule, we write it with small letter n, or you just write the rule multiplied by small letter n. If you multiply 2 by small letter n, you're going to get 2n. That is, if you want to put it in this form, there's going to be 2 multiplied by n, which is 2n. Now, you have the rule, which is 2, multiplied by a small letter n. Since the first term and the rule, they are the same thing, nothing will be added to this and nothing will be subtracted. You just have the nth term formula to be equals to 2n. Nth term formula to be equals to 2n. But if it is in a case where you have your first term, which is the starting point, to be greater than the rule. If your first term is greater than the rule, it means your nth term, whatever you have here, it will be the rule with n, with something that will be added to get the first term. I don't know if you get what I'm saying, but by the time we are in the third sequence, you understand better. But for the first sequence, you don't have much stress when the first term and the rule is the same, because you're just gonna write the rule multiplied by small letter n, which is 2n. And since the rule and the first term, they are the same thing, no addition, no subtraction, this is just the n term. The n term for this first sequence is 2n. Okay, for the second sequence, which is 3, 6, 9, 12, the first term, which is the starting point, is 3. If you look at the sequence very well, you discover the relationship between the first and the second term is 3. The add of 3. From the second term to the third term, you add 3 again. And from the third term to the fourth term, you add 3. So the rule is add 3. The relationship between the term of the sequence this time around is add 3. So we go to the nth term. The n-term formula for this sequence, let's check on the rule. The rule is add 3 and the first term is 3. So the rule is add 3, the first term is 3. So we just write the rule, which is 3 with a small letter n multiplied by n. And checking up the rule and the first term, they are the same thing. So we are not going to write or subtract anything from this 3n. So the n-term formula here also is 3n. Is that taken? So we move to the third sequence. The third sequence is 3, 5, 7, 9, 11, and so on. Here the first term is 3. The first term of this sequence, the first term is 3. If we look at it very well, the connection between the terms, let's try to get the connections between the terms. From the first term to the second term, we can see the difference of 2. From second to third, difference of 2 again. From third to fourth, you can see the difference of 2. Third to fifth, difference of 2. So the rule here is add 2. So for the nth term formula, for this sequence, we discover in this third sequence, the first term and the rule, they are not the same thing. So we're going to write the rule, which is 2, to be multiplied by n, small letter n. So when we now look at 2, compare it to the first term, what are we going to do to 2 to be able to get 3? We are going to add 1 to 2 to get 3. So since the rule is less than the first term, we're going to get the difference between them. What are we going to do to the rule to be able to get the first term? And what we'll do in this case is to add 1. When you add 1 to 2, you get 3. Depending on the number you are given as the first term and the rule. But you write the rule with a small letter n, then check up the rule and the first term. If they are the same thing, you are good to go. But if they are not the same, you're going to get the number or look for what you're going to do with what you already have in order to get your first term. Like what we have done here, we have 2n. Just check up with the figure. The rule is add 2. So what are you going to do to 2 to be able to get 3? You're going to add 1. And so therefore, the nth term for the third sequence is 2n plus 1. And mind you, viewers, when you are able to establish the nth term of any sequence, you can get any number of term of the sequence. Any number of term. Maybe the third term, the fourth term, the million term, the billion term. Any term you're just given or you're just asked to find, you can always work it out because you got the nth term, and from the nth term formula, you can always substitute any number of term you're asked to calculate and come up with your result straight away. So that's fine. Thanks for watching, viewers. Do like, share, and subscribe to my YouTube channel. Bye.